Good day, ladies and gents. We're going to be doing day 10 of our EOC review. Part 1 is on special right triangles, and part 2 is on trigonometry. Now, before we start, let's go ahead and look at this very important information here. So I definitely suggest that you guys take a picture of it if you don't already have these hot topics pages. Let's talk about this a little bit. So first of all, for 45, 45, 90, this is x, and the third side would be x radical 2. For a 30, 60, 90, now it started off as an equilateral triangle, as a 60, 60, 60, where the outside is 2x, and then when we fold it, this will turn in x. So this is 2x is the hypotenuse, the short side is x, and the fold, or the long leg, the fold would be x radical 3. So we can definitely know like x, and the one side we're missing will be x radical something, and in this case be x radical 2. The way you can remember that is that it came from two equal sides, so x radical 2. For a 30, 60, 90, it came from an equilateral triangle, so we can definitely know the hypotenuse is 2x, the short leg is x, the fold is the one thing we don't know, and that'd be x radical what? It'd be x radical 3, because originally it came from an equilateral triangle where it had 3 equal sides. All right, now how can we do this? Step 1 would be ignore any variables they already gave to you. Step 2 would be label the x, the 2x, the x radical 3, or the xx and the x radical 2. Step number 3 would be to solve for x. Set the side number equal to what you labeled as. So here's a good example. If you have 5 is equal to x radical 2, you would divide both sides by radical 2, and then you might have to copy, paste, or erase to simplify that, because we're not allowed to have a radical in the bottom, so you move it to the top and you leave the number behind. And if you can simplify that more, you would. All right, so once you find your x, then step number 4 is plug in. So anywhere you see an x, you plug it in. You plug in this new number. So for example, in this case, 2 times x. So it's 2 times whatever x is. Let's say that our x was 2 radical 3. So you'd plug in 2 radical 3, and you simplify it and you get 4 radical 3. In this case, x radical 3. So it's whatever x was times radical 3. So what if your x was 2 radical 3? You would plug it in, and then you would simplify it, radical 3. So whole numbers go with whole numbers, radicals go with radicals, and here are some examples on how to solve that even more. And then here are some more examples of solving. Okay, so let's go ahead and just start with that. All right, so let's go ahead and do part 1. Okay, so what we have here, roof trusses often use right triangles to make flimsy 2x4 more rigid to hold up the weight of a roof. So far, I have no idea what's going on. I heard the word roof. Okay, if a house has 40 feet wide and it's an isosceles triangle and the base angles is 30, how far from the bottom edge of the roof to the peak? All right, so we're gonna make a triangle. So an isosceles triangle. All right, so let's do that. That means this and this are equal. The base angles are 30. So this is 30 and this is 30. And we know that it's 40 wide. So this is 40 right there. So all this is 40. They want to know the edge of the roof to the peak. So they want so here's the roof, right? The edge of the roof to the peak. So the edge would be here, the peak would be up here. So they want to know what this is right there. So that's our goal, to find this. Okay, so if this is 30 and that's 30, so if I take 180, subtract that 30 and 30, this would be 120 at this moment. Okay, now if I fold this in half, this would be 60 and 60. So hopefully everyone can agree with that. All right, so we have this right triangle right here, and that's a 30, 60, 90, 30, 60, 90. All right, so if I focus just on that, where this is 30, 60, and this is 90. And we know for a fact right here to here, so if this is 40, I would know that this is 20. Because this would be 20, this would be 20, right? All right, so let's focus on that. And our goal is to find this right here. That's our goal. All right, so I'm going to zoom in on that a little bit. All right, so if I zoom in on that part, we know that this would be, so it would fold out like this, right? To make 60, 60, 60. So this would be 2x, this would be x, and this would be x radical, is it 2 or 3? It'd be x radical 3 because it came from 3 equal sides, right? Okay, now let's solve for this. So we have 20 is equal to x radical 3. Solve for x. So I'll write it over again so you can follow my steps. I'm going to divide both sides by radical 3. These cross out, and I cannot leave a radical in the bottom, so I'm going to move up to the top and leave the number behind. And that's as simple as that part gets. All right, so we're going to put that back into here. So this right here, if I put this into here, that'd be 20 radical 3 over 3. This would still be 20, and this would be whatever 2 times 20 radical 3 over 3 is. And if I simplify it, 2 times 20 radical 3 over 3 would just be 40 radical 3 over 3. And that is what I was looking for. So I'll zoom out a little bit. I'm going to write my answer right in here, 40 radical 3 over 3. And that is the final answer for number 1. All right, awesome. Okay, so let's just keep going. All right, number 2. All right, in sailing, it is not possible to go straight. You can't go straight. You cannot go straight into the wind. In order to get upwind, a sailboat simply sails at an angle to the wind and then turns to the sail back towards where it wants to go. So right now I have no idea what's going on, so I'm just faking it. Assume that a boat needs to go directly upwind, so upwind 6,000. All right, so let's do this. I want to go up 6,000. If it sails at a 45-degree angle to the wind, then turns 90 degrees. So basically, I'm going to go like this. So 45. And then I turn 90. And then this would also be 45, right? How far would it have to sail to go directly upwind 6,000 meters? So what I'm looking for is this and this. I'm looking for all of that. Okay, let's do it. All right, so I know that this is x, and this is x radical. Is it 2 or 3? That'd be x radical 2. All right, let's do some work. We have 6,000 is equal to x radical 2. I'm going to write it over again so you can follow my steps. I'm going to divide both sides by radical 2. These cross out. And then I cannot leave a radical in the bottom, so I'm going to move it up to the top. So 6,000 radical 2 and leave the 2 behind. It's equal to x. Oh, look, 6,000 and divide by 2, that's really 3,000. So 3,000 radical 2 is equal to x. All right, 7 over 4, plug in. So we're going to take this, we're going to plug it back in. So that's 3,000 radical 2. And over here is 3,000 radical 2. Okay, now always answer their question. These tricky buggers did not just want x. They wanted this entire distance. So it's this and this. They wanted all of this. So what we want to do is 3,000 radical 2 plus 3,000 radical 2, which equals 6,000 radical 2. That right there, that is our answer. So 6,000 radical 2 was your final answer for number 2. Awesome. So be careful of those tricky little buggers. Okay. And number 3. So number 3, an architect is planning a new town square. So the square has the sides of 20 feet. A walkway will go diagonally. So we definitely need to know the word diagonally. All right, so we have a square, and that's 20. But let's go ahead, but we know all of it's 20, so 20, 20, 20. 20. And diagonally means this. How long will the walkway be? All right, so this is the walkway. This is what we're looking for right there. That's what we're looking for. Okay, so we're looking for that. So let's see what we can do. All right, so if I just focus on this, then I know that this is 45 and this is 45, right? And this is 90. So this be x, x, and this is x radical. Is it 2 or 3? X radical 2, because there's 2 equal sides on that triangle. All right, so if this is x, then this would have to be 20 radical 2. And that's all they wanted right there. That's our answer right there. 20 radical 2 was our final answer. Awesome. All right, let's keep going. All right, number 4. All right, number 4. The frame of a garage roof is shown at the right. Well, technically in this picture, it's below us. How long is each of the top pieces? Okay, so each, that means 1. We only want 1 of those pieces. So of the roof, so they only want 1 of these. So they only want this. Express it in radical form. Okay, so all of this is 120. So this right here, this would be 60, and this would be 60. All right, so the fold would go out like this, right? So this would be x, this would be 2x, and this would be x radical, is it 2 or 3? It would be x radical 3. So that'd be x radical 3. Let me zoom in just a little more. All right, so we're going to set this equal to that. So 6 is equal to x radical 3. And we're going to solve. Divide both sides by radical 3. These cross out. I can't leave a radical in the bottom, so I have to copy, paste, erase. So move it to the top and leave the number behind. And 6 over 3, that's really just the number 2. All right, put it back in. So this right here would be 2 radical 3. Let's go right back to 6. And this right here would be 2 times whatever x was, which was 2 radical 3, which is really just 4 radical 3. And that's your answer. So 4 radical 3 is what we wanted right there. Awesome. And that is the answer to number 4. Fabulous. All right, number 5. Number 5, we first need to plot this. I have no idea what's going on. Let's just plot it. So that's 1, -5. So 1, -5. Now, anytime you have zeros, you always want to put x, y either above or below it. The reason is I'm a math teacher, and I still make this mistake when I go too fast. Now, the number is with the x, so it has to be on the x-axis. So that's 5. So it's x. The 5 is with the x, so it has to be on the x-axis. And then this one, the 4 is with the y, so it has to be on the y-axis. The 4 is with the y, so it's on the y-axis. All right, so there's the picture right there. So we're looking at this, and they want to know what kind of triangle this is. All right, the best way to do this is to go ahead and make little right triangles. Find the 3 distances. So basically, I'm doing the Pythagorean theorem. So right there, 1, 2, 3, 4, 5, plus 1, 2, 3, 4 is equal to x squared. Now this first time around, I'm going to show a little more work. Later on, I might go a little faster, but we'll see. All right, so 5 squared plus 4 squared, we get 41 is equal to x squared. I would square root both sides, and we get the square root of 41 is equal to x. All right, so then we do to the other ones. All right, and notice I'm only highlighting as I do it. So this one right here, I start at the point, go towards the corner. 1, 2, 3, 4. So that's 4 squared plus, start at the point, go towards the corner. 1, 2, 3, 4, 5 squared is equal to x squared. Hey, didn't we do a 5 by 4 earlier? Yeah, it's just going to be, so 4 squared plus 5 squared, we get 41 is just going to be the square root of 41. And this last one. This is a perfect example as to why I always start at the point. Because if I start at the corner and count up, I might stop a little too early. So always start at the point. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 9 squared plus 1. 1 squared is equal to x squared. Oops, only helps if you can see it. All right, 9 squared plus 1 squared, you get 82. So square root of 82. All right, fabulous. Okay, so we know for a fact that this is equal and this is equal. That's awesome. So we know at least two sides are equal. So it's definitely not scaling, because scaling, so remember equilateral, isosceles, scaling. Equilateral has 3 horizontal lines, so that means three sides are equal. Isosceles, 2 sides are equal because we have 2 horizontal lines, and scaling has 0 horizontal lines, so 0 sides are equal. So it's either going to be scaling or sorry, it's definitely not scaling, right? Because we need 2 equal sides. It's definitely not 30, 60, 90 because 1, 2, 3 sides are totally different. So we need at least 2 sides. So it's between these two. Okay, so now all we have to do is see. I'm going to zoom in a little bit. All right, so we got to see, is the x and x radical 2, is that happy? Well, let's see. So we have 40 square root of 41, square root of 41, and square root of 82. So we're trying to see, is this happy? So let's see. If we had square root of 41, if that was set in stone right there, so we're starting this, and this is in stone. So this would be, so if we just ignore this part, if this would also be square root of 41, and then this right here, that'd be square root of 41 times square root of 2, right? That'd be square root of 82 if I put those together. So square root of 41, square root of 41, and square root of 82, does that match what we have? Yes, it does. So that does match. So that means that yes, this is a 45, 45, 90 triangle. So that is the better answer. Awesome. Okay, so hopefully that helped you out on that part. We'll zoom out a little bit just in case you want to take a picture of that. All right, and we're going to go to part 2. Ah, yes, part 2. Okay, so this is going to be SOHCAHTOA. So I'll just put that right here. Oh, by the way, if you wanted the 30, 60, 90 stuff, that's this stuff here. So if you want to take a picture of that as well, it's pretty cool information right there. All right, for SOHCAHTOA. SOHCAHTOA. That is an acronym to remember sine of theta equals opposite over hypotenuse. That's SOH. Cosine of theta. Theta means angle, by the way. Angle. That's the angle. Cos of theta equals adjacent over hypotenuse. That's CAH, C-A-H. Tan of theta equals O over A, opposite over adjacent. So tan of theta equals O, opposite, over A, adjacent. So it's just a way to remember this equation. All right, so the basic steps are label HOA. So hypotenuse, so put your finger on the 90, the one side you're not touching is H. Put your finger on the theta, the one side you're not touching is O, and the leftover side's A. And everyone is really good at finding hypotenuse. Put your finger on the theta, and you should be laughing maniacally. Ha ha ha. That's HA. So definitely find your hypotenuse, put your finger on the theta, and you should be laughing. So it look like this, or put your finger on this theta, you'd be laughing like this. Ha ha ha. All right, so you label HOA, which two are labeled, and that will decide if you're using SO, CA, or TOA. Write out the entire equation, plug in what you know, and then solve. Okay, so here are the 3 different things that could possibly happen with those. Now, depending on your calculator, you're either going to type it in straight and get this answer, or if you have a different calculator, you might have to type it in backwards. So if you, or on some of us, if you're typing into the computer, you'd have to type it in backwards like this. Make sure you're getting this number. Either type it in straight, get this number, or you might have to type it in backwards to get this number. So depending on your calculator, that's what you'll need to do. So if you need to take a picture of this right here, please do so right now. All right, sweet. So now here are the three different things that can happen. Okay, so here, let's go ahead and get this going. All right, so on this one right here, you want to label HOA. So put your finger on the 90, this will be H. Put your finger on the theta, I'll be laughing maniacally, so this should be A down here. This would be O, and this is A. All right, what two sides are labeled? That'd be H has something with it, O doesn't, but A does. So for so, ka, toa, which one has an H and an A? That would be ka. So we're going to write down the equation. Cos of theta equals A over H. Plug in what you know. Cos, your theta was 13, equals A, which is X, over H, which is 50. All right. Is X on the top, the bottom, or with the trig? It is on the top. So we're happy. So we're going to multiply. Basically, we're going to take that 50 and multiply it on the other side. So is X on the top, the bottom, or with the trig? So it's on the top. So we're like this one, we're going to take the 4. We're going to multiply it on this side. So it looks like this. So we're going to take this 50 and multiply it on the other side. So it's 50 times whatever cos of 13 is, equals X. All right, so I'm going to put that in my calculator. So I put that in my calculator. A couple things I need to make sure. One, I need to make sure that I'm in degrees. You definitely want to make sure you're in degrees, depending on your calculator. And when that happens, it'll say degrees like right here, depending on what's happening. Okay, so I would do, in my case, I can do 50 cos of 13, and I get this. On my some other calculators, you might have to type it in backwards. So 13 cos equals, and then times the 50. So for most people, make sure you get this, then multiply by the 50. That's probably the safest bet for you. So find cos of 13 first, then multiply by the 50. That's the safest bet. And we get this right here. And they sit around to nearest 10th. So we have, ran out of room, so I'll put it up here. We have x equals 48.7185, blah, 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 blah. Okay, they said nearest 10th. How many zeros does 10 have? 1. So the question is, are we staying at 48.7, or are we rolling to the next number, 48.8? That number is decided by the number after. So the 1. So 0, 1, 2, 3, 4 versus 5, 6, 7, 8, 9. If I drop the ball at the 1, would it roll back home or would it roll to the next number? It would roll back home by gravity, and that is our final answer. So 48.7 is our final answer. Fabulous. All right, let's keep going. All right, number two. So let's label HOA. So put my finger on the 90. The one side I'm not touching is H. Put your finger on the theta. I should be laughing maniacally, so this will be my A, and the one side I'm not touching is O. All right, so what two sides are labeled? That'd be H has something, O has something. A doesn't have anything, right? All right, so for so, ka, toa, which one has an H and an O? And that'll be so. Write out the equation. Sine of theta equals O over H. Sine of, well, theta, I don't know what that is, so let's call it X. O, which was 50, H, which was 75. Now, is X on the top, the bottom, or with the trig? It is with the trig. So it looks like this one right here. So it looks like this one right here. See that? Okay, to get rid of that, you have to do the inverse. So to get rid of the tan, I had to do tan inverse on the other side. So I'm going to move this sine onto the other side. So it'll be X equals, put this on the other side, sine inverse of 50 over 75. All right, I ran out of room, so I'll put it up here. All right, so now I just have to type that in my calculator. So X equals, so put that in my calculator, I do sine inverse. So on this lovely calculator, I want the sine inverse. So that's this blue right here. To get to the blue, I have to push the blue button first. So I do second, and then I can push this, and now that's second sine. Well, it's the same idea on all the calculators. In order to get to this light blue, I have to push this light thing first. So this, and then sine, and now have sine inverse. And then I would do the 50 divided by 75. Okay, 50 divided by 75, and I would get 41.8103, blah, 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 blah. And they said round to the nearest angle. So they didn't say tenth or anything like that, so that means whole number. All right, so I want to know, are we staying at 41 or are we rolling to the next number, 42? That's what they're asking. So that is decided by the 8. If I drop the ball at 8, that would be right over here. So the answer was 42. And that's it. Awesome. Okay, so hopefully that's helping you guys out on that one. Okay, keep going. And make sure you guys are doing this on your calculator to make sure you're getting the same numbers. If you're not, make sure you check with your teacher that you know how to use your calculator. That's definitely majorly important. All right, number 3. Okay, this one. Now you see how they gave you 2 angles? So that means you're going to have to draw 2 triangles. So we have 35 and 25. So 35 is bigger, so that's the fatter one. And 25 is right here. Okay. Now they said angles of depression. Now I agree that that's the angle up here, but if you do the ultra interior angles, they're going to land down here anyway, and that's what it says down here. So angles of elevation depression, it's always going to land down here anyway. It doesn't matter. So if I do my Z, so depression right there, it's going to land in these bottom corners. Just might as well go ahead and throw them down there. It just saves you so much time. Okay, so we're going to make these right triangles. Doesn't really matter if you get these backwards. It doesn't hurt anything too badly. All right, so this would be the 25. This would be the 30. 35, sorry. 35. Okay, and they said that it is 265 above sea level. So 265 goes right here. So 265, 265. Okay, so, and they want this down here, right? They want this distance, so this be x and x. So we're going to find these and subtract them. Subtract. Okay, and just always give me the positive number. Give me the positive. So positive. So if you get these backwards, just give me the positive number and you'll still be okay. All right, so we're going to label HOA, H-O-A. And I would get, that would be TOA. TOA, tan, sorry, didn't mean to flip that. Tan happens a lot, so it'd be tan of 25 equals 265 over x. And now x is on the bottom, so we're sad, right? So x is on the bottom, so we're sad, so we're going to switch. So this is what I'm talking about. So x was on the bottom, so we're sad, so we're going to switch these. The x goes over here, and the tan 37 goes all the way down here. So you're switching this entire thing. So the red and the purple, they switch. So the red and the purple, they totally switch, and then you would get this. All right, so let's go ahead and put that in ours. So we're going to switch these, so it'd be x equals 265 over tan of 25. And the same thing is going to happen over here. So tan of 35 equals 265 over x. And we're going to end up with x equals 265 over tan of 35. So notice that both of these were the same. We just had to switch. We had to change the numbers. Okay, so we're just going to type this in our calculator. 265 divided by tan of 25. We get 568.29. 433 1 2 3 4 5. So at least go 5 digits when you're doing your work. At least go 5 digits while you're doing work. Do not round yet. Okay, do the same thing for 35. We get 378.45922. All right, 1, 2, 3, 4, 5. Okay, no rounding yet. Okay, now we're going to subtract these. So subtract those two numbers. So 0.29433 minus the 378.45922. And we would get 9.83511. Now that we have our answer, now we can round. Okay, and did they say anything about rounding? How much? They did not in this case because I'm silly and had a typo. So just go ahead and give me the whole number. Just give me a whole number. Okay, so that one right there, that would, so the question is, are we staying at 189 or are we going to 190? That decision is made by that 8. That would drop here. The answer was 190. Cool. All right, so that was just a typo. Typo. So that was a typo. I just forgot to put, hey, give me the whole number. All right, so give me the whole number on that one. That was just a typo. They'll definitely say that one way or the other when you have a test or anything. All right, let's go to number 4. All right, so on number 4, okay, you are 55 feet away from a tree. All right, I have no idea what's going on. Let's just draw this. Okay, so we have a tree. You are 55 feet away from a tree. Awesome. The angle of elevation. Now, it's always going to be in that bottom corner. Angle of elevation is, which are 4.5 off the ground. So the tree is a little taller. Okay, you are 4.5 feet off the ground. And to the top of the tree is 61 degrees. All right, awesome. How tall is the tree? Okay, so we're going to focus on this part. We need to find this, but we know also that this is 4.5. All right, so we're going to find this, but we want this entire distance after we're done. Okay, so we're going to go ahead and solve for this. Here we go. All right, so we are going to do that this is 55, this is x, so this is h, this is o, and this is a. All right. So we have so, ka, or toa. So, ka, or toa. That's a and o, which is toa. So tan of theta equals o over a. Tan of 61 equals o, which is x, over a, which is 55. All right, x is on the top, so we're happy. So we're happy, so we're going to multiply. So it's going to be 55 times whatever tan of 61 is. So if I put that in the calculator, 55 times tan of 61, or 61 tan times that, if I put that in my calculator, I get this. Get 99.2226. Now, I could put 2 or 3. It's really supposed to be 3. And then a bunch of other stuff equals x, right? Now, I did not round yet because I wasn't done. I still have to add that 4.5. So plus this 4.5. And my answer would be 103.7226265, right? And they said it's nearest foot, so that's nearest whole number. So am I staying at 103 or going up to 104? That 7 says, hey, go to 104, and that's my final answer. So be careful with those. So there's the answer for that one. Fabulous. Ooh, we're on the last one. Woohoo! Number 5. Okay, they were nice enough to give us the picture. A roof is shaped like an isosceles triangle. So isosceles, that means this side and this side are equal. The slope of the roof makes a angle of 24 degrees, 24, 24, with the horizontal side, and has an altitude of 3.5. Altitude, so that's altitude right there. Determine the width of the roof. So they want all of this. That is our goal. We want the entire shebang right there. Okay, so let's focus on one thing at a time. So let's call this x. We're actually can't call that anything yet. All right, so this right here. So we're going to want both of these here in a minute. All right, so if I focus on this, I need to do SOHCAHTOA, right? So I need to find this thing right here. So this would be, yeah, you can call it x. So we're going to call that x. So this is, this would be my H. And then here's the angle. So this would be my O, this would be my A. So let's go find that. All right, so that would be, I have this thing and I have this thing. So that would be TOA. So TOA is the thing that we're using. So tan of theta equals O over A. So tan of 24 equals O, which is 3.5, over A, which is X. All right, so now is X on the top, the bottom, or with trig? It's on the bottom, so we're sad. So we're going to switch those. So that'll be X is equal to 3.5 over tan of 24. So if we put that in our calculator, so 3.5 divided by tan of 24, we get X equals 7.861128.709. Okay, so and now they'll put that back in the picture. So 7.8 and a bunch of stuff, and this, and don't we know that this will be the same thing? So that's also 7.8 and a bunch of stuff. So all we have to do is put those two together. So what we're gonna do is 7.861128.709 plus 7.861128.709. So we're gonna add those two together. Or you just multiply by 2, and we get 15.72225.742. And that is the thing that we want. And they said to round to nearest tenth. So they want nearest tenth. So that's 1 0, so that's 1 decimal place. So the question is, are you staying at 15.7, or are you going to the next number, 15.8? That decision's made by the number after, that 2. Now that 2, if I drop the ball at 2, which is right here, it rolled back home. So our final answer was 15.7. And that's it. So we covered everything that we needed to do. I hope that helped you guys out. Have a great and wonderful day.